9. Ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and liftoff.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
Barack Obama, der lässigste US-Präsident aller Zeiten. Hier vor dem Kuss. Er wünscht dem US-Team alles Gute für Olympia. Soweit zum Tagesgeschäft eines Präsidenten. Beim Spiel danach sollte es eigentlich um Basketball gehen. Die Obamas entspannen im Publikum und irgendwie kuscheln sie da auch schon. Und dann die Kisscam. Beim ersten Mal zögert Obama noch. Irgendwie ist er ja auch im Dienst. Beim zweiten Mal schlägt er zu. So macht man das, Herr Präsident. Und weil es in so einer Turnhalle mehr als eine Kamera gibt, hier nochmal. Und nochmal. Man achte auf das Anfeuern von Tochter Malia im Hintergrund. Dass so ein Präsidentenkuss Glück bringt, kann nicht ganz ausgeschlossen werden, denn das US-Team hat am Ende locker gegen Brasilien gewonnen. Vielleicht sollten die Obamas einfach öfter küssen, so im Dienste der Nation.
A 550-second test of the J2X rocket engine has been successfully conducted on the A2 test stand at the Stennis Space Center. It was the first flight duration test of the engine's nozzle extension, a bell-shaped device designed to increase engine performance. The J2X will power the upper stage of NASA's planned two-stage space launch system, the SLS, which will propel the Orion crew capsule beyond low Earth orbit. This test is the latest in a series of firings to gather critical data for development of the J2X. In Yuma, Arizona, NASA completed another successful drop test of the Orion crew capsule's parachutes. The test used an actual-size Orion test article. The vehicle was dropped from a C-17 at an altitude of about 25,000 feet. The main objective was to see how the system would respond if one of the three main chutes inflated too quickly. It's another milestone on the road to Orion's orbital flight test, Exploration Flight Test 1, EFT-1, scheduled for 2014. Expedition 3233 Soyuz Commander Yuri Malenchenko, NASA flight engineer Sonny Williams, and flight engineer Aki Hoshide of the Japan Aerospace Exploration Agency are settling into their new digs aboard the International Space Station. The trio was welcomed aboard the orbiting laboratory by Station Commander Gennady Padalka, NASA flight engineer Joe Akaba, and Russian flight engineer Sergei Revin. The docking of their spacecraft came on the 37th anniversary of the historic link-up of Apollo and Soyuz spacecraft in 1975 that began U.S.-Russian cooperation in human spaceflight. International Space Station program scientist Julie Robinson was at the Marshall Space Flight Center's Payload Operations Center to encourage ISS ambassadorship among employees. Robinson is traveling to NASA centers to promote a better understanding of the research and technology development being done in the world's only laboratory in microgravity.
Those scientific discoveries and the way that they benefit us here on Earth are really some of the most important messages that NASA needs to share with our taxpayers about how valuable the space station is and how much it's driving our economy. So we're just trying to make sure that our own employees know those messages, and then we're trying, of course, to also share them with the world.
The Payload Operations Center at Marshall coordinates all research activities aboard the station. NASA astronaut Dan Burbank visited Goddard Space Flight Center to share experiences from his 5-month stay aboard the ISS as a member of the Expedition 29 and 30 crews.
If you ride a rocket to space, as soon as the engines quit, within the first hour, you're already becoming a creature of space. Your body is doing exactly what it needs to do to optimize all the resources you have to live in this new and novel environment that it finds itself in.
Burbank and his crewmates, Anton Shkaplerov and Anatoly Ivanishin, returned to Earth on April 27th. Aero Day on the Hill, provided an opportunity for representatives of NASA's Aeronautics Research Mission Directorate to visit Capitol Hill and brief members of Congress on the research the agency is conducting to make air transportation more efficient, safe, and environmentally friendly.
We are setting the vision for the country, and we are leading the aeronautics community. So it's all about direct, tangible, compelling benefit that you can enjoy today and years to come.
ARMD works to solve the challenges that exist in our nation's air transportation system through innovative technical concepts and dedicated research and development. Space Shuttle Enterprise made its official debut before New York's public as the centerpiece of the Intrepid Sea, Air, and Space Museum's newest attraction, Space Shuttle Pavilion.
Let's cut the ribbon.
Today, we turn Enterprise over to the Intrepid Sea, Air, and Space Museum. This magnificent machine is a tangible example that our dreams of exploration, of reaching our higher potential, are always within our reach if we try for them.
Also part of the grand opening celebration, a host of NASA exhibits, displays, and educational demonstrations showcasing the past, present, and future of aeronautics and space exploration. Event guests met and mingled with a number of current and former NASA astronauts.
Noted space historian John Logsdon spoke at the Kennedy Space Center to detail some of the decisions then-President John F. Kennedy made to set the nation on a course to send astronauts to the moon.
That it was the Gagarin flight, and in particular the domestic and international reaction to the Gagarin flight, that stimulated Kennedy to pay attention to human spaceflight, and as he paid attention, become to realize the symbolic importance of not being in a leading position.
Logsdon said Kennedy made defining contributions to keep the Apollo program on course during the rest of his presidency.
Get to the moon before the Soviets, that was Kennedy's overriding motivation.
Logsdon, who has written extensively about the American space program and space policy, said the president spoke often about involving the Soviet Union in a joint venture to the moon, even going as far as to propose the idea before the United Nations.
Kennedy's first choice would have been to cooperate from the start, and it was Khrushchev that said no.
Of course, Apollo 11 met Kennedy's challenge by putting 2 men on the moon before the end of the 1960s. And 6 years later, the United States and Russia began their cooperation in human spaceflight that eventually led to our partnership on the International Space Station.
4 forward, drift into the right a little.
30 seconds.
Forward, drift. Contact light. Okay, engine stop. Tranquility Base here. The Eagle has landed.
July 20th marks 2 important events in NASA history. 43 years ago, on that date in 1969, Apollo 11 astronauts Neil Armstrong and Buzz Aldrin helped NASA meet the challenge set forth by President Kennedy of putting Americans on the moon before 1970, when the duo became the first humans to step foot on another heavenly body. While Armstrong and Aldrin collected the first lunar soil and rock samples on the surface, Command Module pilot Michael Collins kept vigil in the Columbia module orbiting above. The 3 reunited and landed safely in the Pacific Ocean 4 days later. And 36 years ago, on July 20th, 1976, the Viking 1 lander separated from the orbiter and touched down at Chrysae Planitia to become the first spacecraft to successfully land on Mars and perform its mission. Together with Viking 2, which landed a month later, the orbiter imaged the entire surface of the red planet, transmitting high-resolution photographs of its terrain that characterized the structure and makeup of its atmosphere. Viking 1 also took and analyzed surface samples for composition and signs of life. Much like its successors, the twin rovers Spirit and Opportunity, the Viking spacecraft were designed for 90-day missions, but produced valuable data for years. 40 years ago, on July 23, 1972, NASA, in cooperation with the U.S. Geological Survey, launched the first Landsat satellite from California's Vandenberg Air Force Base. Known at that time as the Earth Resources Technology Satellite, It was the first Earth-observing satellite launched with the expressed intent to study and monitor our planet's landmasses. Landsat-1 operated until January 1978, 5 years past its designed lifespan. 5 Landsat satellites have since been sent into orbit. The program represents the world's longest continuously acquired collection of space-based, moderate-resolution land remote sensing data. Imagery that provides a unique resource for everything from agriculture and geology to education and emergency response and disaster relief.
Good morning, this is Mission Control Houston. Welcome and thank you for joining us now for a look back at this week aboard the International Space Station. The 6 crew members aboard the station include Russian cosmonaut and commander of the complex Gennady Padalka and flight engineers cosmonaut Sergei Revin, NASA astronaut Joe Acaba, and now the cosmonaut Yuri Malenchenko, NASA astronaut Sunny Williams, and Japanese astronaut Aki Hoshide. The newest crew members of Expedition 32, Malenchenko, Williams, and Hoshide, arrived at the International Space Station aboard their Soyuz TMA-05M and docked to the Rassvet module of the space station at 11:51 p.m. late Monday night. Then the hatches opened early Tuesday morning at 2:23 Central Time. The new trio will close their first week in space today, and meanwhile aboard the station to greet their new crew members, Padalka, Revin, and Acaba, will be completing their 68th consecutive day in space. And now let's look back at this week aboard the International Space Station. On Monday, the station crew had a shorter day with a sleep period 6 hours earlier than normal to accommodate the arrival of the 3 new crewmates. Before their early sleep period, the station crew members had worked with a variety of ongoing science and maintenance activities. Revin had worked with the Radiation Payload Suite, Matryoshka, which is designed for sophisticated radiation studies and is named after the traditional Russian set of nested dolls. Then Commander Padalka worked in the Russian segment of the station, monitoring its systems and performing preventative maintenance on the ventilation system, while Acaba performed some training with the robotics onboard trainer. This is to prepare for the rendezvous and capture of the Japanese Aerospace Exploration Agency's 3rd H-2 transfer vehicle that is set to launch to the station tonight at 9:06 p.m. Central Time. Acaba also performed some maintenance on the Express Rack 5 utility drawer lid hatches. 3 new Expedition 32 crew members docked to the Rassvet module of the International Space Station late that night at 11:52 p.m. Central Time. Then flight engineers Sunny Williams, Yuri Malenchenko, and Aki Hoshide launched aboard their Soyuz TMA-05M, their spacecraft, at 9:40 p.m. Saturday from the Baikonur Cosmodrome in Kazakhstan. Again, they arrived to dock to the Rassvet module of the International Space Station at 11:51 p.m. Central Time. Then on Tuesday, NASA astronaut Sunny Williams and Russian cosmonaut Yuri Malenchenko and Japanese astronaut Aki Hoshide joined their Expedition 32 crewmates as their new flight engineers when the hatches between their Soyuz spacecraft and the International Space Station officially opened at 2:23 a.m. Central Time, Tuesday. Commander Gennady Padalka and flight engineer Sergei Revin and flight engineer Joe Acaba welcomed their new crew members aboard the orbital home for the next 4 months. After participating in a welcoming ceremony with family and mission officials at the Mission Control Center in Star City, Russia, the newly expanded crew quickly went to work. Padalka and Revin had conducted a session with the bar experiment, which looks at methods and instruments for detecting the location of a loss of pressure aboard the station. Acaba then swapped out and recharged a battery associated with the integrated cardiovascular experiment, which measures the atrophy of the heart muscle that appears to develop during long-duration spaceflight. He also performed some maintenance on the minus 80-degree laboratory freezer. Then Williams, Hoshide, and Malenchenko unloaded items from their Soyuz spacecraft as well as outfitted their new crew quarters. And then all 6 crew members then participated in a safety briefing to review their roles and responsibility in the event of an emergency. Then on Wednesday, new flight engineer Aki Hoshide spent some time reviewing the station's exercise equipment. However, most of his day was spent on the robotics training for the arrival of Japan's HTV cargo vehicle known as Kunitori 3. Flight engineer Joe Akabe joined Hoshide in the robotics training. The Kunitori 3 again is scheduled to arrive at the station on July 27, when it will be grappled with the Canadarm2 and berthed to the Harmony node. Akabe also powered up the ham radios in the Columbus laboratory and the Zvezda service module. He demonstrated the treadmill operations to Hoshide and flight engineer Sonny Williams, who were new to the International Space Station. And Williams had worked on 2 ongoing science experiments for the InSpace 3 experiment. Wednesday's objective was to restore an even distribution of particles inside a fluid. Benefits include the production of smarter and stronger materials. She also reviewed operations for the BASS experiment, or burning and suppressions of solids. Then flight engineer Sergei Revin on Wednesday studied potential ways to detect a pressure loss in the station for the BAR experiment. And Commander Gennady Padaka concentrated on maintenance inside the station's Russian segment. Flight engineer Yuri Malenchenko performed maintenance as well, transferred gear from the Soyuz TMA-05M, and also conducted crew orientation activities. Then on Thursday, flight engineers Sonny Williams, Yuri Malenchenko, and Aki Hoshide joined Commander Gennady Padaka and flight engineer Sergei Revin and Joe Akabe for a review of crew emergency roles and responsibilities. Akabe and Hoshide then performed some training again with the robotics onboard trainer to prepare for the rendezvous and capture of the Japanese HTV cargo vehicle, the Kunitori 3, that is set to launch to the station tonight again at 9:06 p.m. Central Time. The rendezvous capture and berthing of the cargo vehicle are scheduled for July 27th. Then, to prepare the Space Station Progress 47 cargo vehicle for its undocking, Padaka and Malenchenko installed a docking mechanism and also ran some tests with Toru, the Russian telerobotically operated rendezvous system. Williams worked with the burning and suppression of solids BASS experiment. That experiment examines the burning and extension characteristics of a wide variety of fuel samples in the microgravity. And Sergei Revin worked with the typology experiment, which studies changes in cosmonauts' reaction time during the long-duration spaceflight. Meanwhile, on Thursday, Hoshide participated in an in-flight educational event for the Japan Aerospace Exploration Agency. He spoke with students in Tanegashima and also Scuba Japan. And today, Friday, July 20th, Commander Padaka continues final preparations for this weekend's departure of the Progress 47. This is the Russian cargo ship for its undocking this weekend. The Progress 47 vehicle is set to undock from the Piers docking compartment Sunday at 3:27 p.m. Central Time. The cargo ship will back away from the station and then redock on Monday night. The vehicle's undock and redock exercise is to test a new cruise docking system. We'll have live coverage of the initial undocking on Sunday afternoon at 3 p.m. Central Time here on NASA television. Meanwhile, flight engineer Joe Akabe removed and replaced the water recovery system's recycle filter tank assembly for urine processing of the onboard water recovery system that converts urine, sweat, and condensation into drinkable water. And Akabe then conducted a fitness evaluation and a periodic health checkup with some help from his crewmate, flight engineer Sonny Williams. Akabe then assisted Williams with an integrated cardiovascular ambulatory monitoring system that studies the atrophy of the heart muscle during long-duration spaceflight. Also today, Akabe, Williams, and Hoshide worked together in more onboard training using the station robotics to practice vehicle rendezvous and capture in advance of the arrival of the third Japanese cargo supply ship, H-2 transfer vehicle, or the Kunitori 3. CABA also will prepare the Node 2 Nadir hatch for the arrival of the vehicle. The cargo ship is scheduled to launch from the Tanegashima Space Center in Japan tonight at 9:06 p.m. Central Time. We'll have live coverage of the cargo ship's launch here on NASA television beginning at 8:15 p.m. Central Time, 9:15 p.m. Eastern Time. And also today, flight engineer Sunny Williams performed the reversible figures experiment. She also will spend time on an entry as part of the journal study and participate in a private medical conference. Meanwhile, today, Hoshide review procedures for the -80-degree laboratory freezer, and then also removed and restored the current list contents of the lab aft stowage location and moved some space hardware to that location. The newest crew members aboard the International Space Station will also have more time today for additional adaptation and familiarization. The crew is scheduled to go to bed at 5:30 p.m. Central Time. This is Mission Control Houston. We've been doing a lot of talking about the Kunotori 3. It is scheduled to launch tonight from the Tanegashima Space Center in Japan. Aboard that cargo spacecraft, we have about 3.5 tons of cargo that is scheduled to go up. 20% of that cargo is experiment-related equipment. And so here to talk with us today, we have Pete Hasbrook. He's the Associate Program Scientist. Welcome, Pete, and thank you for coming.
Thank you very much. I'm glad to be here today.
Well, so as we were saying, there's about 3.5 tons of cargo that is scheduled to go up. 20% of that cargo is experiment-related equipment, and a lot of our equipment that's actually going up. And so Pete is here to talk to us a little about that. But first, I'd like to talk a little about you.
Okay.
So tell me first how you came about coming to NASA, how you made your way to where you are now.
I've been at JSC for 27 years. I grew up in Michigan, studied aerospace engineering at the University of Notre Dame, and came here to the Mission Operations Directorate right out of school. I held 2 different positions on the shuttle flight control team in operations, and then about 10 years ago I came over to the Space Station Program Office, which is the program management of the International Space Station. About a month ago, I started my new job, which is the Associate Program Scientist.
Wow, so you're new to this thing. So I understand, so you were an increment manager, and so you obviously know a lot about the ISS or Space Station operations, and so we'll get into some of that as well, as obviously there were some station operations and also some partnership things that took place for getting our payload on board. The cargo ship that is scheduled to go up. And this is the second operational Japanese cargo ship that's going up, correct?
Yes, it's the third of the HTV vehicles. The first one was a demonstration mission. It was fully successful. And so now the second and third are the ones that we've relied on for all the good cargo.
Okay. So a month into your position as the Associate Program Scientist, explain a little bit about that.
So a program scientist, as a part of the International Space Station Program Management Office, the program scientist represents the science aspect of the station. The station is a laboratory. It's a huge laboratory. It's a huge complex to manage, so there's a lot of competing interest in managing that, keeping the crew safe, keeping the crew supplied, keeping all the systems up and running, keeping the crew healthy. But we want to use the laboratory for its purpose, which is science, investigations. We also want to do that as the international partnership, which is set up. And that's kind of where I come in. My previous job as an increment manager was a mission manager, and I worked extensively with the international partners. Now, in the Program Science Office, I will be focusing on, again, working with the partners, but now more on collaboration, making sure we're using the station effectively, communicating with those partners, looking for synergy and collaboration. And then the other part of what a Program Science Office does is we report on what we're using the station for. Some of that is reporting to management, reporting to our partners, reporting to headquarters in Congress, how effectively we're using the station, and then also educating the public, whether it's educating our NASA employees to go out and talk to the public, or just in general something like this, telling people what we do. We have people today in New York for the opening of the Enterprise at the Intrepid Museum. Some of our office are out there telling people about what we do.
Very interesting. So now I want to talk about some of the things that are going up, because we do have a lot of really interesting things, and I'm really glad to hear that you refer to the space station as a laboratory, because I think sometimes we forget that it's not just an orbital home flying in space that is there that we're sending people up just to maintain. There is a reason that we are there, and that is for the science that we are able to bring up. And so obviously, like I said, there's about 20% of that 3.5 tons of cargo that is being launched to this space station. That launch, again, is going to be 9:06 p.m. tonight. We'll also have coverage of the launch at 8:15 p.m. here on NASA television as well, for those of you who are watching. So let's get into some of those things that are going up. One of the payloads, the NASA payload, that is going up aboard the HTV-3 is the SCAN testbed. Now, SCAN is an acronym, excuse me. Space, Communicators, and Navigation.
Yes.
So explain to me what that is.
Okay. The SCAN testbed is it uses one of the unique capabilities of the HTV, in that HTV can launch external cargo that never comes inside the station, but it gets mounted outside the station. In this case, the SCAN testbed is demonstrating advanced radio technology. The principal investigator is at Glenn Research Center. The other major investigators are at the Goddard Space Flight Center, as well as the Jet Propulsion Laboratory. It's in demonstrating new communication methods, for instance, the software-designed radios. Traditional radios have a lot of internal hardware components, transistors, tubes, the converters. This new technology uses computers more, uses modems, and it's a reconfigurable radio in a sense that you can launch it on a spacecraft, let's say, and then if something changes, like you can reduce the power level because you don't need as much power, you can do that through your commanding. You don't have to bring the radio back to the ground. It's also testing advanced navigation technologies. And the SCAN testbed is going to be removed by the robotic arms on the station, and it will be transferred up to an external location on the station, so it can see satellites, communicates in several different wavelengths.
Okay. Okay, great. Well, so I think one of the benefits you mentioned was the fact that, so basically we can fly that piece of hardware there, but then we don't have to keep bringing it back and forth. And so essentially it's just a software swap out, correct?
It's using new hardware. It's demonstrating how that hardware can be commanded from the ground, change the software inside that hardware. Another advantage of using the station, you could launch this hardware on pretty much any satellite that's going around the Earth and test it. But the station is there. It's a national laboratory, so it's an opportunity for us to take equipment to our laboratory and demonstrate it.
Okay, very good. Interesting. So let's move on to another one I found very interesting. And there's a long list of things that are going up there, so we're really only just touching base on a few items. But one of those things is the aquatics habitat. Now, this I just find very interesting because we're talking about fish in space.
I do too, yes. The aquatic habitat is going to go into the Japanese experiment module. It is the aquarium system that will let the Japanese scientists study fish. There are no fish in this aquarium yet, but it's setting the systems up. It's a complicated system. If you think of an aquarium, it's got pumps and filters, and through the filters it puts oxygen back in the water for the fish. The neat thing to me was, imagine an airlock to get outside the station. Well, some way you need to get the fish in microgravity. So there's basically a water lock where eventually the fish will come up in some kind of a container, and you have to transfer them into the aquarium without letting the water get loose. The fish that they're going to study are the Medaka fish. Here in the U.S., our researchers use mice because we understand mice, we understand them as a model of the human body, so we understand if a mouse reacts in a certain way to a drug or a disease, how that might apply to the human body. The Japanese have a history of studying fish, and the Medaka fish is a model for them of the human body. So in a sense, they've got so much history on the ground. If you fly the fish and study it in microgravity, you understand the history of how it reacts on the ground, so you can apply that to what you're seeing in microgravity.
That makes sense, and it's really, really kind of exciting to think about fish in space and an aquarium. Can you describe for me about the size of this aquarium, what the aquarius habitat?
The facility itself is probably about 1 meter wide. It's going to go in a half rack in the gem. The fish will be inside a much smaller container in that rack. It's about 7 centimeters by 7 centimeters by maybe 15. That's how big the aquarium is. The fish themselves are fairly small, so they fit in there. the aquarium not only has the life support systems for the fish, as I said, it's also got cameras that can monitor the fish as they're progressing, see how they're doing.
Okay, and then what type of fish are we talking about? Freshwater, saltwater?
I believe they're freshwater fish.
Okay.
Don't quote me too much on that.
I'm going to quote you. You're on TV.
Yeah, I know.
Okay, so another major science aspect that we work on continuously is Earth observations for a number of reasons. And so we've been doing that for, just in the crew Earth observations for many, many years. And so obviously, and there's obviously really great advantages of the vantage point of the space station, not only from where it flies, but the fact that it flies all around the world at many, many times in even one given day, and literally can cross every part of the Earth. So I understand we have a new camera, and this is called the iServe. This is an Earth observing camera that's going to be brought up, and this is a remote controlled. And so if you can explain to me how it is remote controlled.
Okay. The iServe camera is a new design. It's the result of a cooperation of NASA and USAID, the Agency for International Development, I believe it is. The idea is that we want to use satellite and spacecraft technology to the data that comes from those, pictures of the Earth, rainfall, and get that out to governments. And in this case, one of the major users is the Surveyor Network in what they call Mesoamerica, so Central America and the Caribbean. Countries that don't have access a lot of times to space-based data, but are affected quite a bit, whether it's earthquakes or rain or flooding or hurricanes. And the idea here is let's use the station's capability and our imagery to get that out to these governments so they can see what's going on in their countries and their countryside and make decisions about how to respond to disasters or potential disasters. The station has a great window in the laboratory. It's an optical quality large window, and we're going to use it with this new camera. This camera is really a digital camera looking down the barrel of a bigger telescope, about an 8-inch telescope. This telescope is on gimbals, so the ground can command it to one side or the other of the ground track. The program will know when we're going over various parts of the Earth, and if there's something that the ground wants to see, they can set it up to take pictures of specifically the area and then share that.
Okay, and so it would only require, as far as crew time, just to activate it, or is it all automatic?
Basically, to initially set it up, set it within the window, set up the computers. It's controlled by a laptop computer, so it's a very small footprint. Once the crew sets it up, the ground will be able to monitor it. The ground will be able to predict it. The ground will be able to command it to change and take the pictures and downlink the pictures.
That's very efficient. So, and again, those photographs that are taken of the Earth are not only beautiful to look at, but they actually do serve a purpose for, some research that we are doing here to help understand. And obviously, in those development countries where they don't have the capability of being able to study those, and especially that they are hit with things like hurricanes and tsunamis and, wildfires and that sort of thing. Not only from a disaster standpoint, but also from an environmental changes part, correct?
Yes, yes. So these cameras can take a history of the ground areas that they're looking at, whether it's a seasonal history or years in the making history, see how things are changing. You can use that to say this area needs more fertilizer. This area is at risk of mudslides. So it's a good way to use the technology. Another benefit of the station is it's at relatively low altitude. So the pictures are closer to the ground. We can get better resolution.
Very good. That's interesting. So now another one, and this is kind of a fun one, I think, is the YouTube Space Lab.
Yes.
Tell me a little about what that is.
As we know, I'm new to this office and I've just been learning about it, but in the last couple of days, as I've looked into the YouTube Space Lab competition, I'm really impressed with what they've done. This is what we call an educational outreach, public outreach activity. It was sponsored through YouTube and public sponsors, and the target is kids in, let's say, middle school, high school. There were two age ranges, 14 to 16 and 16 to 18. And it was to get into this competition, the idea was pick something in physics or in biology and propose an experiment to be done on the International Space Station. And to do that, you had to submit a 2-minute video of yourself, introducing yourself, what your concept was, what your hypothesis was, how you would test it, and how would you use your results. They had something like 2,000 entries. They've had millions of views on this YouTube website. So they narrowed it down to about 60, I think, finalists, and part of the voting to select the final was through the public voting on the YouTube website. They narrowed it down. The 2 finalists are having their experiment launch on the HTV, and it will be operated by the crew. And the neat thing that I saw as well, Sunny Williams was the one who announced the winners. I think it was last December or January. She's on board now. She will be the one executing the experiments. There were 2 teams or 2 individuals that won. One was a set from Michigan, my home state. 2 young ladies that proposed a biology experiment. They saw that results of previous research that said salmonella gets more virulent on station in microgravity, meaning that it's more effective, and in that case it's more dangerous to you. Well, they thought, we know of an antifungal, let's fly that. And the premise is, if it works this well on the Earth, maybe in microgravity it does an even better job. And we care long term about fungus on ISS. You get mold on walls, it's a bad thing. It can deteriorate your walls, your metals on board. So they proposed this experiment. It's got what we call controls on the ground. They're going to monitor how the fungicide reacts on the ground, and then see how it reacts after having flown in space.
Wow, I'm always amazed when we have some of these educational type research projects that are going up, because there are a lot of smart kiddos out there, let's face it. And it's really neat that we're able to send that up there. And, it's in the end, what we learn from that in turn helps us as well.
I think we may have the website here, but if you go search on YouTube.
We do. It's at that website again. It's at www.youtube.com/spacelab. So you can go and look at all the videos that they have there and the contest. And I know there are a couple of Q&A, scientific Q&A videos there as well. So have a visit and check that out. And now I want to talk about, so like I said, we have a huge list of things that are going up, and that's, really good, because again, like you said, space station is a lab, and that is what it is. So like I said, 3.5 tons of cargo is going up aboard the Kounotori 3, again, the second operational cargo ship from Japan. So I want to talk a little about the space station operations and the international partnership.
Okay.
How we get this stuff to Japan and on that spacecraft and up to the space station. How do we work with our international partner?
We first off, we need to decide what we're going to fly, and we have projections on how much food the crew eats, what they're going to need to wear, how much medical equipment they need. We also have an extensive process of looking into the future and what science will be ready to fly, what science we need to fly in that time frame, what the crew will be trained for. So there's a process to look at all that and divide up the cargo allocation among the crew supplies, among the emergency and maintenance supplies, and then especially we want to get as much utilization or research hardware on board as we can. So once we've defined that, we know what hardware needs to fly. There's a manifesting process, as we call it, that says this is how much it weighs, how big it is, this is when it can be delivered. There's a lot of folks that work with the scheduling and delivering the hardware, making sure it's safe, making sure it's packaged correctly. That then is delivered, in our case here at JSC, and then it's shipped over to Japan and turned over to the Japanese to load into the vehicle.
Okay. And how far in advance did they send our cargo to Japan and for the loading? How long did that take, do you know?
I don't know. I wouldn't even.
You're new. You've been here a lot.
It was also a part of my old job that I didn't do so much in.
Well, that's okay. We won't hold you to it.
Okay.
So again, we have another website you can go to learn more about these things that we talked about and the rest of that list. If you go to www.nasa.gov/mission_station pages/station research. Now, the easy way to go there is www.nasa.gov/station. On the left-hand navigation, just click on research and you can find the whole list there. You can search it by experiment name, alphabetically, you name it.
We have a couple areas, if I can interrupt. We have areas specifically for researchers. For if you have an experiment that you want to fly on the space station, there's a section for researchers. There's a section for teachers, for educators, how we can get NASA projects into your classroom. And then for students or for kids, there's another section that say, I have an idea for something I want to fly on space station. There's a section for them on there.
Great, thank you so much. And also, if you want to follow along,
yes, please.
More of the research, go to Twitter, twitter.com/ISS_research. I'm sorry, not slash, it's just ISS_research on Twitter. You can learn everything that's going on. The newest updates will be there. And thank you so much, Pete, for coming. And again, we all look forward to the third space cargo spacecraft from Japan launching tonight at 9:06 p.m. Central Time. And we will have live coverage for you here on NASA television at 8:15 p.m. Central Time, 9:15 p.m. Eastern Time, and then that cargo spacecraft will then dock to the space station with all this good stuff aboard on the following Friday on July 27th. This is Mission Control Houston.
(18:45 Uhr) RTL aktuell mit diesen Themen. Blutbad im Kinosaal. Bei der Premierenvorstellung des neuen Batman-Films erschießt ein junger Mann in Denver 12 Menschen und verletzt viele schwer, darunter 2 Kinder. Ein maskierter Mann hat in einem Kino der US-Stadt Denver ein Blutbad angerichtet. Während der Premiere des neuen Batman-Films stürmte er in den Kinosaal und schoss um sich. 12 Menschen starben, 38 wurden verletzt. Möglicherweise fielen einige von ihnen der Panik im Kino zum Opfer. Aus den USA berichtet Carsten Mierke.
Die Situation vor dem Kinocenter war für lange Zeit völlig unübersichtlich. Verstörte Besucher irren herum, immer mehr Polizei rast herbei und Dutzende Rettungswagen bringen über 50 Verletzte in Krankenhäuser. Handyvideos zeigen, wie blutüberströmte, torkelnde Menschen aus dem Kino geführt werden. Es ist fürchterlich, da war dieses junge Mädchen mit Schusswunden und Blut überall. So etwas will ich nie wieder sehen. Es war die Mitternachtspremiere des dritten Batman-Filmes, als rund 20 Minuten nach dem Start das Drama begann. Der Typ brach durch den Seiteneingang, er hatte einen Kampfhelm auf, eine schusssichere Weste und er war ganz in schwarz mit einer Schutzbrille. Und er zündete eine Gasgranate. Zunächst dachten einige noch, es sei ein PR-Gag, denn auch der Schurke im mit Spannung erwarteten neuen Batman-Film trägt so eine Ausstattung. Doch im Kinosaal bei Denver, Colorado, war es furchtbare Realität. Ich habe das alles erst gar nicht begriffen. Erst als die Leute schreiend wegrannten, habe ich mich auf den Boden geworfen, um mich zu schützen. Die Polizei nahm den mutmaßlichen Täter auf dem Parkplatz an seinem Auto fest. Polizeibeamte fanden bei ihm eine Gasmaske sowie je ein Gewehr und eine Pistole. Später durchsuchten sie mit einer Feuerwehrleiter sein Appartement von außen, denn die Wohnung war mit Sprengfallen bestückt. Ein Motiv für all das aber gibt es bislang nicht. Präsident Obama gedachte in Florida mit einer Schweigeminute der Opfer. Auch wenn wir wissen, wer es war und was genau geschah, wir werden nie verstehen, was so jemanden antreibt. Solche Gewalt, solches Übel ist sinnlos. Die Gewalt, das Übel bescherte den USA die schlimmste Bluttat seit vielen Jahren.
Ja, und dazu eine Nachfrage an Carsten Mierke in New York. Carsten, die Polizei hat den Täter festgenommen. Was weiß man über ihn und sein Motiv?
Man weiß nicht viel, er ist weiß, er ist 24 und er heißt James Holmes. Polizeilich ist er nicht weiter aufgefallen, bisher außer eines Strafzettels in 2011. Es gibt noch ein paar Unklarheiten über eine Aussage seiner Mutter. Sie soll einem amerikanischen TV-Sender gesagt haben, sie haben den Richtigen, aber man weiß nicht so genau, was sie damit gemeint hat. Auf jeden Fall ist das alles sehr, sehr gut vorbereitet. Das FBI bescheinigt den Sprengstofffallen in seinem Apartment, die seien sehr raffiniert und man werde Stunden, wenn nicht gar Tage brauchen, um das alles aufzuräumen. Aber ein Motiv für all das hat man bislang nicht gefunden.
Carsten Mierke, live aus den USA. Vielen Dank für diese Informationen.
Die Woche geht bewegend zu Ende. Wir berichten gleich vom Attentat bei einer Batman-Premiere in den USA. Aber auch die Schüsse gehören zum Film, so dachten viele Zuschauer in der Mitternachtsvorstellung. Der neue Batman hatte in der vergangenen Nacht in Aurora, einem Vorort von Denver in Colorado, Premiere, Vorpremiere, das Kino war voll.
Ja, doch die Schüsse gehörten nicht zum Film. Es war Realität. Kugeln durchschlugen Körper, töteten und verletzten. Ein Amoklauf. 12 Menschen kommen ums Leben, Dutzende werden verletzt. Das Ende einer Kinovorstellung, über das heute überall gesprochen wurde.
Der Täter ist ein 24-jähriger Mann. Sein Motiv für diese Wahnsinnstat liegt im Dunkeln.
Saal 9 im Century-Kino war voll besetzt, vor allem mit Familien und Jugendlichen. Dementsprechend jung sind die meisten Toten. Das jüngste Opfer soll ein Baby sein, gerade 3 Monate alt. Ich sah ein kleines Mädchen, das blutüberströmt war, sagt dieser Augenzeuge. Ich rechnete sofort mit dem Schlimmsten. In den ersten Sekunden waren wir noch nicht in Panik, aber dann rannten alle zum Ausgang und rauf ins Obergeschoss. Da sahen wir dann die vielen Polizisten mit ihren Waffen. Der Täter kam über eine Treppe, nachdem der Film angelaufen war, mit einer Gasmaske und ganz in Schwarz gekleidet. So taucht er plötzlich vor der Leinwand auf. Erst wirft er Rauchbomben in die Zuschauerreihen, dann zielt er mit einer Waffe ins Publikum. Panik bricht aus. Dann flüchtet der 24-jährige Täter aus dem Gebäude. Die Polizisten erwiderten das Feuer und fanden den Attentäter auf der Rückseite des Kinos in einem Auto. Er hatte eine Gasmaske auf und mehrere Waffen dabei. Sein Motiv ist völlig unklar. Ob es etwas mit dem Film zu tun hat, mit der Geschichte von Batman? Es ist der letzte Film der Batman-Trilogie. Dessen Europapremiere in Paris heute Abend ist abgesagt und die deutsche Kinokette Cinestar will besondere Sicherheitsvorkehrungen ergreifen, wenn der Film nächste Woche nach Deutschland kommt. Den Attentäter mit seiner schusssicheren Weste und den Waffen hatten viele Zuschauer zunächst gar nicht als Bedrohung empfunden. Auch im Publikum waren viele verkleidet. Die meisten vermuteten, der Täter sei Teil der Inszenierung der Filmpremiere. Nicht nur für Michelle und mich, sagt Barack Obama, für die ganze amerikanische Nation war das ein Stich ins Herz. Inzwischen hat die Polizei die Wohnung des Mannes durchsucht. Von außen ist ein Spezialkommando durchs Fenster gestiegen, denn in der Wohnung hat der Attentäter, der einen Doktortitel in Neurowissenschaften hat, Sprengfallen montiert. Es könne Stunden oder Tage dauern, bis die entschärft sind.
Zurück nach Deutschland.
Amoklauf im Kino. Ein Mann erschießt in den USA mindestens 12 Menschen. Ein Amokläufer hat bei der Spätvorstellung des neuen Batman-Films in einem Kino im US-Bundesstaat Colorado 12 Menschen erschossen und 38 verletzt. Der Täter hatte erst eine Rauch- oder Tränengasbombe gezündet und danach wahllos auf die Zuschauer im Saal gefeuert. Augenzeugen berichten, dass der Amokläufer kurz nach Mitternacht in das Kino in Aurora, einer Stadt bei Denver, stürmte. Das Kino liegt zentral neben einer großen Einkaufsmall. Die Polizei hat einen 24-jährigen Mann festgenommen. Einen terroristischen Hintergrund gibt es offenbar nicht. Heike Slansky berichtet.
Bilder aus dem Kinofoyer. Blutverschmiert und völlig verstört verlassen die Besucher den Saal, unterstützt von Polizeikräften. Panik, Schreie, Schockstarre. Die Mitternachtsvorstellung des neuen Batman-Films endet im Chaos. Es gab Explosionen hinter mir und Rauch, aber ich dachte erst, es sei ein Scherz, es gehört zur Show, ein Feuerwerk. Doch dann verließen immer mehr Menschen den Saal und es stieg noch mehr Rauch auf. Fassungslos versammeln sich die Überlebenden vor dem Kino. Dutzende wurden verletzt, 12 Menschen sterben an den Schussverletzungen. Es war furchtbar. Ein junges Mädchen mit Schusswunden am Bein und Blut überströmt. So etwas will ich nie wiedersehen. Nachdem panische Anrufe in der Notrufzentrale eingegangen waren, rasten Polizei und Feuerwehr zum Tatort. Das Kino wurde sofort weiträumig abgesperrt. Wir haben den Täter hinterm Kino gefunden, auf dem Parkplatz in der Nähe eines Autos. Er hatte eine Gasmaske bei sich, ein Gewehr und eine Pistole. Der Morgen danach. In der Wohnung des Täters findet die Polizei Sprengfallen. Das Wohngebiet wurde evakuiert. Der 24-jährige Todesschütze James Holmes, ein Student der Neurowissenschaften, für die Polizei bislang ein völlig unbeschriebenes Blatt. Präsident Obama zeigte sich entsetzt, brach seine Wahlkampftour ab. Zuvor sagte er: Eine Tragödie. Die Nation müsse jetzt zusammenstehen als eine amerikanische Familie. Offenbar, so die Polizei, handelt es sich um einen Einzeltäter. Amerika ist schockiert.
Ja, wir haben es gehört, die Polizei geht von einem Einzeltäter aus. Christoph Röckerath, was weiß man inzwischen über diesen Täter und sein Motiv?
Ja, wir haben es ja gerade im Beitrag gehört, was die Sache so schwer macht, ist, dass der Mann eben polizeilich ein völlig unbeschriebenes Blatt ist. Er ist ein junger, weißer, 24-jähriger Student an der Universität von Colorado. Und es macht es so schwierig. Es gibt keinen Platz für voreilige Schlüsse. Er gehört keiner ethnischen Gruppierung an. Es gibt keinen, soweit man es zumindest bis jetzt weiß, politischen, etwa rechtsradikalen Hintergrund. Das Einzige, was auffällt und was die Menschen hier besonders entsetzt, ist die Methodik und das kaltblütige Vorgehen. Er hatte sich hier angezogen wie für einen Kampfeinsatz. Kugelsichere Weste, Gasmaske, Schutzhelm, Sonnenbrille. Alles war so ausgerichtet, dass er möglichst lange und gezielt Menschen töten kann, was er auch gemacht hat. Er ist ganz ruhig durch die Kinoreihen gegangen, haben Augenzeugen gesagt, und hat ganz gezielt auf Menschen geschossen und sich dann ja auch gestellt. Das heißt, er wollte anscheinend überleben. Er wollte nicht sich dabei selber ums Leben kommen, hat sich nicht umgebracht. Und das zeigt, vermuten zumindest manche, dass er jemand ist, der die Aufmerksamkeit sucht. Aber das ist alles Spekulation. Genaues kann man erst sagen, wenn die Polizei die Wohnung durchsucht hat. Das dauert noch an, weil noch immer dort die Sprengfallen, die sehr subtil gebauten, sehr gut gebauten Sprengfallen sind, die erst entschärft werden müssen. Also ich denke, es wird noch 1, 2 Tage dauern, bis man mehr weiß.
Ja, das waren Informationen unseres Amerika-Korrespondenten Christoph Röckerath. Vielen Dank nach Washington.
Einblicke in unser Universum errechnet von einem Supercomputer. Es klingt sonderbar, aber damit wir besser verstehen, wer wir sind und woher wir kommen, gibt es große, warme, schwarz lackierte Schränke, wie die des neuen Großrechnerstars Supermuck. Solche Computer sind heute unverzichtbarer Teil wissenschaftlicher Forschung.
Neben der Theorie und dem Experiment überprüft man Annahmen dadurch, dass man die reale Welt auf dem Computer nachbildet und errechnet, ob das, was man annimmt, dann auch wirklich stimmt.
Ein Beispiel: Die Berechnung von Gesteinsbewegungen im Erdmantel soll dabei helfen, Erdbeben besser vorhersagen zu können. Für solche Berechnungen brauchen die schwarzen Schränke vor allem eins: Rechenleistung, viel davon. Im Inneren von Supermuck steckt davon so viel wie in etwa 110.000 normalen PCs. Der Computer kann in einer Sekunde 3 Billiarden Rechenoperationen durchführen. Supermuck ist der viertschnellste Rechner der Welt und der einzige dieses Formats, der ganz besonders gekühlt wird.
Der Rechner ist direkt mit warmem Wasser gekühlt. Das heißt, da gibt es einfach Kühlkörper, wo Wasser durch die Kühlkörper fließt. Und das Besondere daran ist, dass das Medium Wasser hinsichtlich Kühlungseffizienz um Faktor 300 effizienter ist als Luft.
Die Warmwasserkühlung braucht weniger Strom, ist deshalb günstiger als eine Kaltwasserkühlung. Supermuck ist auch energieeffizient, weil die Geräteabwärme durch Wasserrohre in alle Institutsgebäude fließt und zum Heizen genutzt werden soll. Nicht ganz unwichtig bei einem Projekt, für das Bund und Land Bayern gemeinsam rund 130 Millionen Euro bezahlt haben.
Schlechtes Wetter, vor allem beim Nachmittagstraining zum großen Preis von Deutschland, war schuld daran. Michael Schumacher zeigte unfreiwillig einen spektakulären Abflug.
Michael Schumacher trat ab wie ein Sieger. Dabei hatte er seinen Boliden gerade in die Barriere gesetzt. Bei wiedereinsetzendem Regen kurz vor Schluss an vorletzter Stelle liegend. Alles reparabel bis zum morgigen Qualifying. Seine Fans immerhin mal wieder ganz unerwartet auf Tuchfühlung.
Ich meine, dass die Fans sich freuen, mich zu sehen, das ist zum Glück so. Und natürlich sind die Umstände unschön und unpassend, aber die hören zum Rennsport auch dazu.
Teamgefährte Rosberg als bester Deutscher Zweiter vor Vettel. Allerdings regnete es da nicht.
Auf einer abtrocknenden Piste schneller zu fahren, das ist jetzt für mich nicht so wichtig.
Denn ihm war der Regentest wichtiger, auch wenn es schief ging.
Nach und nach trudeln sie ein in der britischen Hauptstadt, die ersten Athleten. Willkommen in London, willkommen zum ersten Streik. Ausgerechnet in der ganz heißen Phase, einen Tag vor der Eröffnung, wollen Britanniens Grenzbeamte die Arbeit niederlegen, wegen zu niedriger Gehälter. Die deutschen Kanuten kann das nicht mehr belasten. Die sind schon da und haben bereits die ersten Trainingseinheiten auf der nagelneuen Wildwasserbahn nördlich von London hinter sich. In typisch englischem Nieselregen.
Es ist ein bisschen regnerisch hier, aber das macht uns ja eigentlich nicht so viel aus. Wir werden ja so oder so nass.
Die gute Nachricht für Nicht-Wassersportler: Nächste Woche soll das Wetter besser werden.
Soziale Netzwerke können Fans eine richtige Lichtshow erzeugen. Wissenschaftler haben eine Formel entwickelt, die die Kommentare bei Twitter auswertet. Das Ergebnis wird dann jeden Abend um 21 Uhr zu bewundern sein. Dabei gilt, je positiver die Meinungen, desto imposanter die Lichtspiele.
Der Supermuck hat 3 Petaflops. Klingt jetzt bescheiden, 3, sind aber 3 Billiarden Rechenoperationen pro Sekunde. Unsere Zahl des Tages mit 15 Nullen. Der Rechner in der Nähe von München kann alle Physiker oder Mathe-Freaks in Deutschland und ganz Europa glücklich machen. Man kann mit ihm so bescheidene Dinge simulieren wie die Entstehung des Universums. Zum Vergleich, 3 Billiarden Flops hat der Supermuck und der erste Computer hatte 2 Flops.
Right now at the Tanegashima Space Center, the HTV-3 sits atop its H-2B rocket. The weather in the area is doing fairly well. They are expecting and taking a look at some lightning that may or may not be in the area at the time of our launch, but we'll keep our eye on that. But the rocket is fueled and ready to go. This evening's launch time is 9:06 p.m. Central Time, 10:06 p.m. Eastern Time. The HTV-3 is a 16.5-ton cargo carrier that serves the International Space Station. It is bringing up almost 4 tons of supplies and experiment hardware to the crew. You see the breakdown of the different sections of the HTV-3 here. At the far right-hand side, or at the bottom of the cargo carrier, is the propulsion module. It's about 6.5 feet long and carries all of the fuel for HTV. There are 4 propellant tanks that carry 2 tons of fuel on each flight. There are 4 main thrusters located at the bottom of the propulsion module, along with 16 reaction control system thrusters that help fine-tune HTV's flight. Another 12 thrusters are located at the top of the HTV for a total of 28. Beside the propulsion module is the avionics module, which contains the guidance, navigation, and control system, as well as the communications, data handling, and electrical power systems. All of these systems combined together help the HTV fly on its own during the trip up to the International Space Station, which, as we mentioned, takes about a week. That avionics module is about 4 feet long, which gives you a sense of exactly how big this cargo carrier actually is. The next section is the unpressurized cargo hold. It measures about 11.5 feet long and has a wide opening that accommodates the exposed pallet, which you see diagrammed there. This pallet is the large tray. It looks just like a drawer that carries on it several different pieces of equipment that are installed on various portions of the International Space Station. The exposed pallet has what's called an FRGF, which is a flight releasable grapple fixture. It's a very fancy title for the piece of equipment that's on it that the station's robotic arm grabs onto, and that's what allows it to be withdrawn from the HTV itself. On the far left-hand side is the pressurized logistics carrier. This is at the very top of the HTV. This section's almost 11 feet long and carries all of the cargo that is used on board the station. There's a hatch on one end of the HTV, the far left-hand side. That is what the crew will use to get access to the cargo carrier to actually go inside and unload it. Inside it are different resupply racks that have different cargo bags attached to them. That is how all the different cargo is secured inside this cargo carrier, and that is what the crew will actually be unhooking and opening up and unloading all the different cargo over a series of days. Once again, a live view of this H-2B rocket with the HTV up on top of it. As we mentioned, the rocket is fully fueled. That happened about 6.5 hours ago. The Japanese control team there, both in Tanegashima and also at the Scuba Control Center just outside of Tokyo, are reporting that everything looks good to go for this evening's launch here, once again at 9:06 p.m. Central Time, 10:06 p.m. Eastern Time.
The HTV-3 actually has an extended ascent profile, meaning that it takes a little bit longer to get into orbit than some of the other spacecraft that we cover here on NASA television. Typically, that's about 8 or 9 minutes. It takes about a little more than 15 minutes for HTV-3 to get up into orbit. So once again, liftoff will occur at 9:06 p.m. Central Time. And then at 1 minute and 54 seconds into the flight, that is when the 4 solid rocket boosters will burn out. That point in the flight, the rocket will be more than 30 miles high. A few seconds after that, at 2 minutes and 4 seconds into the flight, the first pair of solid rocket boosters will jettison themselves, followed just a few seconds later by the second pair. So this is unlike other vehicles where the SRBs come off all at the same time. These come off in pairs, so it's quite a spectacular sight to see if you've ever seen one of these HTV launches. At 3 minutes and 40 seconds into the flight, about 75 miles up, the fairing that protects the HTV will be jettisoned, and at that point, HTV-3 will be exposed. Then at 5 minutes and 47 seconds, that is when the first stage engine will cut off. And then at 5:54, the first and second stages will separate from one another. At 6 minutes and 1 second into the flight, that is when the second stage engine will ignite. And then it will burn for pretty much the remainder of the flight up until the 14-minute and 20-second mark. That is when it will be cut off. And then, as we mentioned, at 15 minutes and 11 seconds into the flight, that is when HTV-3 will separate. Its preliminary orbit is 200 kilometers by 300 kilometers, which equates to 124 by 186 miles. As you see this liftoff occur here coming up in a little less than 45 minutes, you will notice that the HTV-3, along with its H-2B rocket, will do a pitch maneuver much like what the shuttle used to do. It will be heading to an azimuth, which is basically the angle at which it flies into space, at 108.5 degrees. So you will see that happen with this giant rocket. The HTV control team there in Japan has notified the flight director here in Houston, Scott Stover, that they're going to be doing the go, no-go for the Houston team a little bit earlier than expected. So Stover is talking with his team now, just making sure that everybody is ready to support the flight and that everything here in Houston and at our other partner centers are green down the board. As you can see from this live view of the Tanegashima Space Center, the HTV-3 and its H-2B rocket definitely do not lack for a view there at the Space Center and this launch pad. The Space Center was created in 1969 when the original National Space Development Agency of Japan was formed. It later on became JAXA, the Japan Aerospace Exploration Agency. But the HTV will be lifting off from launch pad number 2 there, which has been the site of the other HTVs. Of course, this is the third HTV that has flown. The first one was September 10th, 2009. That was the liftoff date for the maiden voyage of this huge cargo carrier. The second one was in January 22nd of 2011, so a little more than a year and a half ago. Once again, our launch, 9:06 p.m. Central Time, 10:06 p.m. Eastern Time. Everything is looking good to go. Everything is reporting green from the NASA side and all of its partner agencies. As we mentioned, Scott Stover has just wrapped up talking to the other control centers around the world, including the Columbus Control Center. And once he receives word from the Moscow Control Center, we should be able to give a report to the JAXA colleagues that everything is good to go from the standpoint of our side. As you can tell, this H-2B rocket is just huge. It stands 186 feet tall and is a two-stage rocket, as we were talking about a few minutes ago during the ascent profile. You see the breakdown of the rocket there with the HTV up at the top, the payload fairing which covers it. It uses liquid oxygen and liquid hydrogen as propellants. There are 4 strap-on solid rocket boosters on the side of the rocket to help power the flight during the first couple of minutes. There are 2 liquid-fueled engines on the bottom of the first stage as well, which you see as those LE-7A engines. Tonight's launch will begin a week-long process of getting the HTV-3 up to the International Space Station. The capture of the cargo carrier itself is scheduled for July 27th, 1 week from now. HTV-3 will fly pretty much the exact same flight profile that the other 2 HTVs did, as well as something very similar to what the SpaceX Dragon spacecraft did. Joe Acaba, who is part of Expedition 32 at this point in time, will be responsible for operating the station's robotic arm to reach out and grab onto the HTV-3. Once that takes place, Aki Hoshide will take over, and he'll be responsible for installing it to the Harmony node, which is the home of HTV-3. Sonny Williams will be providing some backup operations, helping the crew with anything that is needed. Scott Stover has just informed the HTV control team and our counterparts over in Japan that the team here is officially go for the launch of the HTV-3, so everything is looking good to go from all the different control centers around the world. So again, once HTV-3 arrives at the station on the 27th, the crew will actually open up the hatches and go inside the pressurized section on the 28th, the very next day. They will extract that large exposed pallet, which is the drawer that carries experiments on top of it. On August the 6th, you see a couple of the different experiments that are there. The Space Communications and Navigation Test Bed, which is a NASA experiment. It's called SCAN. That will be later on installed on Express Logistics Carrier number 3, which you see out there on the left-hand side of the station. It's a little bit misleading because it looks like it's on the right-hand side of your picture, but the station actually flies with the U.S. segment forward, so technically it is the port or left-hand side. That ELC-3 is up on top. That will be the home of the SCAN test bed. What this does is basically take a look at whether different types of radios that are used on board the International Space Station can be reprogrammed using software. Typically, radios are very specific to the job they are designed for. If you change the mode of operation of a radio, you basically just have to fly up a brand new piece of hardware. So, of course, with space being a little bit difficult to get to, it's important to find out that these radios can be reconfigured and operated differently with different configurations just using a quick software upload. So that is what SCAN will take a look at. The second experiment that's on that exposed pallet is what's called the Multi-Mission Consolidated Equipment Experiment, which you see there. That is a Japanese experiment. It is basically 5 small mission payloads that are focusing on different types of science and technological demonstrations. These include 2 atmospheric observation investigations that study lightning and what's called resonant scattering from plasma and air glow. That's just the residual sort of reflection and lighting that the atmosphere has whenever the crew is flying over the Earth in the dark. There's also 3 technological demonstration investigations as part of that MCE, including an inflatable structure deployment, robotic tether movement, and they're also going to be testing a high-definition television camera up there in space. So again, that exposed pallet will be extracted on the 6th of August. It will be installed on the Kibo Laboratories external payload. That's basically just the front porch of Kibo on the 10th. And then coming up September the 5th, that is when the crew will back out of the HTV-3, close it up. Operations will be done at that point, and then it will unberth and depart on September the 6th. A good look at those solid rocket boosters there on the side of the HTV-3's rocket, the H-2B. Again, those will burn out at the 1 minute 54 second mark. That is when the first pair will be jettisoned. Just a few seconds later, about 10 seconds at 2:04. And then the second pair will be jettisoned 3 seconds later at 2:07. Just 33 minutes and counting until the launch of the HTV-3. The weather there a little bit hazy, as you can tell. We talked about some lightning that they were taking a look at in the area. We've received no reports that is occurring, but we'll keep our eye on the weather there and just pass that along to you as we hear it. The latest weather update there from the Tanegashima Space Center is 83.1 degree Fahrenheit in terms of the temperature. And of course cloudy, as you can tell from the cameras there. The rollout of the HTV-3 aboard its H-2B rocket occurred this morning. It took just a few minutes to roll out, which began at about 5:30 a.m. Central Time to roll it out to the pad. It took right at 18 minutes to get this rocket out to its launch position. The rocket and the spacecraft itself had been prepared inside the vehicle assembly building there at the Tanegashima Space Center. It's about 400 meters from that building to the launch pad. The rocket has moved atop a movable launcher, which serves as the launch pad as well. There are two special transporters named Dolly that move the entire pad out all at once. Each dolly has 56 tires, and the unique thing is that each dolly can move front, back, or even rotate sideways if it needs to be, so it's pretty flexible and can move that rocket into the proper position to get it ready for launch. As we mentioned, fueling began about 7 hours ago, and everything went smoothly during that process. Launch still on target for 9:06 p.m. Central Time, 10:06 p.m. Eastern Time. Again, the weather right at 83 degrees Fahrenheit, cloudy, and they are keeping their eye on that as we count down these final 30 minutes. We're now at T-minus 29 minutes and 23 seconds. You can see the launch pad there being hosed down with water. That is standard protocol. It keeps dust and debris down and also helps sort of calm down some of the acoustic energy that comes off the rocket at the moment of ignition. Very similar to what we used to do with the shuttle on the launch pad. There was a deluge system that would just dump tons of water down. It's a fairly effective way of dampening out some of the energy that comes off these rockets. As a piece of historic trivia for you, it was 1 year ago tonight that we were actually in deorbit preparation on STS-135. The crew was just a couple of hours away from getting Atlantis and themselves ready to return home at the conclusion of that very successful mission, of course, bringing to a close the more than 30-year space shuttle program. So just 1 short year ago, we were witnessing history as the space shuttle program got ready to come to a close there with that crew you see there, Rex Walheim, Doug Hurley, Chris Ferguson, and Sandy Magnus, part of that historic crew.
X-25 分。
This is Mission Control Houston. We're at T-minus 22 minutes and 45 seconds before the launch of the HTV-3 cargo carrier. Launch time 9:06 p.m. Central Time, 10:06 p.m. Eastern Time. As we take a look at the dates that are ahead for the crew of the Expedition 32 as well as this HTV-3, as we mentioned, this begins about a week-long journey up to the station. July 27th, next Friday evening, that is when the capture and berthing will take place on board the International Space Station. Joe Acaba will be in charge of that activity. He'll be using the station's robotic arm to reach out and grab on to the cargo carrier itself. Once that happens, Aki Hoshide will be in charge of moving it on in and installing HTV-3. Once that takes place the following day, that is when the crew will open up the hatches and take a look inside the cargo carrier. That is on July 28th. And on August 6th, that is when the exposed pallet will be extracted from that middle portion of the HTV-3 that we showed you at the beginning of our broadcast. They'll install it on the front porch of the Kibo module coming up on August 10th. And then September 5th, that is when they will button up the HTV-3. It will be uninstalled on September the 6th. And then shortly after that, it will be sent into a destructive reentry into the Earth's atmosphere. Another item of note coming up on Sunday, this crew has just had an incredibly busy time since they've been on board the station. That will not change. Sunday, the Progress 47 will undock from the Pierce docking compartment of the International Space Station. It will back out to a distance of about 100 miles. That's about 160 kilometers back behind the station. And then on Monday, it will reapproach the station to test out brand new Coors system components that were installed inside the station. That Coors system is what allows the Progress and the Soyuz to perform automated rendezvous and dockings with the orbiting complex. There's some new equipment that they're going to be testing out both inside the station and actually on the vehicle itself with a brand new antenna configuration. This will hopefully allow the Progress and the Soyuz to perform these automated dockings with fewer antennas. We're going to have live coverage of this activity coming up on Sunday beginning at 3 p.m. Central Time here on NASA television, with the actual undocking taking place at 3:27. And then on Monday, beginning at 8:15 p.m. Central Time, that is when we will return with live coverage of the redocking of the Progress 47 back again to the Piers docking compartment. That redocking will occur at 8:57 p.m. Central Time. Then a week later, beginning at 1 p.m. Central Time, that is when the final undocking will occur of that Progress 47 with its job being finished up. And then at 1:11, that is when the actual undocking itself will take place. And then on August 1st, the very next day, 2 days later, excuse me, that is when the Progress 48 will launch. At launch time at 2:35 p.m. Central Time, our launch coverage will begin at 2:15. If you notice there, that Progress is going to be docking the same day as it heads up to the International Space Station. The Russians are going to compress that timeline. Typically, it takes about 2 days for Progress and Soyuz to get up to the station, but they're going to be doing it same day. So quite a maneuver to watch as we bring you live coverage of all of this here on NASA television. This is Mission Control Houston, T-minus 16 minutes and 20 seconds and counting until the launch of the HTV-3 cargo carrier on a mission toward the International Space Station. As we mentioned, there's 4 tons of supplies flying on this particular flight. 61% of that are spare parts, 15% is food, 20% is science experiments, and 4% is crew supplies. On previous missions, they have flown some water up to the station. Last time it was about, I think, 2 to 3% water. There is none on this particular mission. The crew is all set in terms of their water needs. Majority of this is spare parts for the station itself, as well as some food for the crew and some experiment hardware. Launch time tonight is going to be 9:06 and 16 seconds on the dot. It'll take 15 minutes and 11 seconds for HTV-3 to get up into orbit. That orbit originally is going to be 124 by 186 miles. That'll be fine-tuned over the next several days as the cargo carrier closes in on the orbiting complex. T-minus 14 minutes and 11 seconds and counting before the launch. A quick update for you on our official launch time. The visiting vehicle officer has updated us. It is 9:06 and 18 seconds. That time was fine-tuned by 2 seconds since the station performed a reboost of its altitude back on Wednesday. So again, 9:06 and 18 seconds. We'll get confirmation from the flight controllers here once we have lifted off this evening. But 13 minutes and 45 seconds and counting. T-minus 12 minutes and counting. Everything still looking green down the board in terms of all the team's readiness to support the launch. The rocket's in good shape. It's fully fueled, as we mentioned, about 7 hours ago. That's when that took place. The liquid oxygen, liquid hydrogen was pumped into this rocket. As you can see, it's venting there. The Expedition 32 crew on board the station is currently in their sleep period. They've got a little more than 5 hours before they're going to wake up. Of course, they'll be getting an update on their daily planning conference, which they have just a couple of hours after wake up, where they talk to the different ground teams around the world, but they will no doubt have some questions about the status of this rocket and this cargo carrier that is heading their way. Once again, Joe Akaba, Aki Hoshide are two primary people that will be responsible for capturing HTV-3 and installing it to the station's Harmony node.
We would like to inform you of a final go no-go decision.
現在、各系ともロケット打ち上げの最終作業を実施中です。また、警戒区域の安全が確認されており、気象条件も打ち上げに支障のないことが確認されました。
All systems are now in final operations. All safety measures were confirmed in the restricted areas. Also, the weather conditions were examined and confirmed.
従いまして、宇宙ステーション補給機コウノトリ3号機 HTV-3 を搭載した H2B ロケット3号機の打ち上げを本日日本時間の午前11時6分18秒に実施します。
As a result, we are to launch the H2B launch vehicle number 3 with the HTV-3 named Konotori on board at 11:06:18 a.m. Japan Standard Time.
そ So an update there from the Japan Aerospace Exploration Agency saying that everything is go to launch the HTV-3. We're at T-minus 9 minutes and 7 seconds and counting. Official launch time will be 9:06 and 18 seconds Central Time. That is 11:06 and 18 seconds there at the launch pad. There's several clouds in the area. The temperature's about 83 degrees. Humidity's fairly high, as you can tell from some of that vapor there at the bottom of the launch pad, both coming off the rocket and some of the mist coming off the sea there. T-minus 8 minutes and counting. This will be a 15-minute and 11-second trip into orbit for HTV-3.
It's 8 minutes to launch. The final terminal countdown starts.
470種子島宇宙センター滝崎総合司令塔から H2B ロケット3号機の打ち上げ状況をお伝えしております。
This is a live report of the H2B launch vehicle number 3 launch from the Takesaki Center at the Tanegashima Space Center.
52、51、現在各系ともロケット打ち上げの最終作業を行っています。また警戒区域の安全は確認されています。
All systems are now in final operations. All safety measures were confirmed in the restricted areas.
フライングしちゃいました。
430、29、28、27、26、25、24、23、22、
T-minus 7 minutes and counting.
420、19、18、17、
安全系準備完了。
The range safety system is ready.
13、12、11、410、409、408、
車上系準備完了。
The range system is ready.
404、403、402、401、400。
This HTV-3 carries also the name Kanatori. That's what they nickname these HTVs. It stands for White Stork in Japanese. 6 minutes and 22 seconds before the launch of this rocket. Everything is reported green from the Japanese flight controllers.
370。
打ち上げ6。現在車上の天候は雨、気温摂氏 27.9 度、南南東の風毎秒1メートルです。 H2B ロケット3号機の打ち上げに問題はありません。
It's 6 minutes to launch. The current weather here is rainy. Temperature is 27.9 degrees Celsius. Wind is 1 meters per second from the south-southeast. We don't have any problem for launch.
330。
本日の打ち上げ予定時刻は日本時間の午前11時6分18秒です。
Today's scheduled liftoff time is 11:06, 18 a.m. Japan Standard Time.
310、309、308、307、306、305、304、303、302、301、300。
T-minus 5 minutes and counting.
5分前です。
It's 5 minutes to liftoff.
The teams are in their terminal countdown now.
The HTV-3 is ready.
290、89、88。
They just reported the temperature of 82.2 degrees Fahrenheit there at the launch pad. There is some rain in the area, as you can tell by the live view of the Tanegashima Space Center.
78、
自動カウントダウンシーケンス開始。
The automatic countdown sequence starts.
72、71、270、69、 68、67、
種子島宇宙センター竹崎総合司令塔から H2B ロケット3号機の打ち上げ状況をお伝えしております。
This is a live report of the H2B launch vehicle number 3 launch from the Takesaki Range Control Center at the Tanegashima Space Center.
52、51、
現在ロケットの管制は吉信発射管制塔から行われています。
The launch vehicle is currently controlled from the Yoshinobu blockhouse.
42、41、240、39、38、37、36、35、34、33、32、31、230。220。
2 minutes, 3 minutes and 30 seconds and counting.
210。200。190、89、88、87、86、85、84、83、82、81、180。
打ち上げ3分前です。
It's 3 minutes to lift off.
全システムの電源が外部から内部に切り替えられました。
The launch vehicle is switched to the internal power.
2 minutes and 44 seconds before the launch. The vehicle is now on internal power. At the moment of liftoff, 9:06 and 18 seconds, the International Space Station will be 255 statute miles over the South Pacific, just off the coast of Chile.
150。140、39、38、37、36、35、34、33、32、31、130。28、27、20、25、24。
2 minutes, 2 minutes and counting.
21、120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105、
2段液体酸素系、液体水素系、準
Liquid oxygen and hydrogen systems are ready.
97、95、94、93、92。
1 minute, 30 seconds and counting.
89、88、87、86、85、84、83、82、81、80、79、78、77、76、75、74、73、72、71、
フレームデフレクター冷却開始。
Launch the flame deflector cooling starts.
66、65、64、
2 minutes, 1 minute and counting.
61、60。
分前です。
It's 1 minute to lift off.
57、56、55、54、53、52、51、50、49、48、47、46、45、44、43、42、41、40、39、38、37、36、35、34。
2 minutes, 30 seconds and counting.
開始。
The launch deck water curtain starts.
29、28、27、26、25、24、23、22、21、20、19、18、17、
フライトモードオン。
Flight mode on.
14、13、
2 minutes, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of the HTV-3 on its way toward the International Space Station.
SRB ignition and liftoff.
すべての人類のために宇宙ステーション補給機コウノトリ3号機を搭載した H2B ロケット3号平成24年7月21日午前11時6分18秒に種子島
For all mankind, we had the liftoff of the H-2B launch vehicle with the Konotori 3 on board from the Tanegashima Space Center at 11:06 and 18 seconds in the morning on July 21, 2012, Japan Standard Time.
打ち上げ以降、ロケットの管制は吉信発射管制塔から竹崎総合司令塔に引き継がれています。
After liftoff,
1 minute into the flight of the HTV-3, obviously it's in the clouds now. The weather there preventing us from seeing the HTV-3, but we're standing by. The solid rocket booster should burn out at 1 minute 54 seconds.
徐々に南東方向の太平洋上へ飛行しています。
The HTV is now flying over the Pacific Ocean to the southeast with its initial flight angle of 108.5 degrees.
ロケットは正常に飛行中であり、種子島地上局は正常にロケットの追尾を行っています。
The H-2B is flying normally, and the Tanegashima stations and Uchinola station are tracking the launch vehicle very well.
100
1 minute 50 seconds into the flight, standing by for confirmation of the SRB burnout. Separation should be shortly thereafter.
13 14 15
SRB へ燃焼終了。
SRB
burnout confirmed. And there goes the first set of solid rocket boosters. It'll be followed by the second set.
第1ペア分離。SRBA
2 minutes 15 seconds into the flight.
and the second pairs of SLBAs were jettisoned.
Two minutes and 40 seconds into the flight. The next major milestone will be at 3 minutes and 40 seconds. That is when the fairing that is currently surrounding the HTV-3 up on top of the rocket will be separated. It'll be jettisoned and will fall away.
Launch 3分が経過します。
3 minutes after liftoff.
第1段エンジンの燃焼、制御系、飛行経路も正常です。ロケットは順調に飛行を続けており、現在の 105km、秒速約 2.29km です。
The first stage engine combustion, attitude control, and flight trajectory are all normal. The flight goes very smoothly. Currently, altitude is about 100. Velocity is approximately 2.29 kilometers.
衛星フェアリング分離。
Payload fairing jetson.
Fairing separation confirmed. Once again, this is the shroud that surrounded HTV-3 for protection up on top of the rocket. So HTV-3 now exposed as the rocket continues its 15-minute and 11-second flight into space. At 5 minutes and 47 seconds, that is when the first stage engine will cut off. The first stage and second stage will separate just a few seconds after that at 5:54. And then shortly thereafter, right after the 6-minute mark, that is when the second stage engine will ignite. That will burn for pretty much the remainder of the flight up until the 14-minute 20-second mark. And that is when that engine will cut off. Here's live telemetry from the Japan Aerospace Exploration Agency as they continue to monitor their rocket as it flies up into space.
Launch 後5分が経過しました。
It's 5 minutes after liftoff.
ロケットは順調に飛行を続けており、現在の高度は約 160km、秒速約 4.37km です。
The flight current altitude 160 kilometers. Velocity is approximately 4.37 kilometers per second.
5 minutes, 45 seconds into the flight, everything looking good.
First stage engine cut off.
And we have first stage cutoff and separation of the first and second stage.
First and second stage is separation.
The second stage engine will now ignite.
Second stage engine ignition.
The visiting vehicle officer here in Mission Control confirming that the altitude of the HTV-3 is 200 kilometers. Currently flying about 5,300 meters per second. Everybody's reporting that the vehicle is under good control and everything is looking right down the middle. Just an incredibly cloudy day there at the Tanegashima Space Center. There was some rain in the area at the moment of liftoff. A very low cloud deck, as you saw. The vehicle disappeared into the clouds pretty quickly right after liftoff. You can see there's some rain showers there on the far right-hand side. Seven minutes and 20 seconds into the flight. Everything's still looking pretty good. Now 8 minutes into the flight. The second stage is still burning.
It's 8 minutes after liftoff.
第2段エンジンの燃焼は正常。制御系、飛行経路も正常です。現在の高度は約 255km、秒速約 5.67km です。
The second stage engine combustion attitude control projectly are all normal. Altitude is about 255 kilometers. Velocity is about 5.67 kilometers per second.
So the HTV-3 continuing to gain altitude now at 255 kilometers. It's moved to about 5.67 kilometers per second. At 5.67 kilometers per second, about 3.5 miles per second. The orbital speed's 5 miles per second. That's what the station travels at. Just an incredible speed. It's roughly 17,500 miles per hour. 9 minutes, 20 seconds into the flight. Again, the second stage continuing to burn. This will continue up until the 14-minute, 20-second point in the flight. It'll shut down, and then separation between HTV-3 and its second stage will occur right at 15 minutes and 11 seconds. So we will continue to monitor the flight of this cargo carrier now headed toward the International Space Station. Everything is working right down the line.
It's 10
10 minutes after liftoff.
ロケットは順調に飛行しています。ロケットは種子島内之浦の各地上局からの捕捉範囲を離れ、小笠原局およびグアム局から追尾されています。
The flight is progressing very smoothly. The launch vehicle is out of the tracking range of the Tanegashima stations and Uchinoura station, and Ogasawara and Guam stations are now tracking it.
approaching the 11-minute mark of the flight. As you heard our counterparts in Japan confirm, it is currently out of the range of the Tanegashima Tracking Center. It's being tracked by some ground stations now as it heads over the Pacific Ocean.
第2段エンジンの燃焼は正常、制御系、飛行経路も正常であり、ロケットは現在安定しています。現在の高度は約 287km、秒速約 6.45km です。
The second stage engine combustion, attitude control, and flight trajectory are all normal. The flight goes very smoothly. Current altitude is about 287 kilometers. Velocity is about 6.45 kilometers per second.
So the rocket now 287 kilometers. That's 178 miles. It is currently moving at 6.4 kilometers per second, or about 4 miles per second. Continuing to speed up as it heads down toward the southeast.
追尾を終了しました。現在、グアム局から追尾を行っています。
The Ogasawara station finished tracking, and the Guam station is now tracking the launch vehicle.
12 minutes, 15 seconds into the flight, everything looking good. We are standing by for that 14-minute and 20-second mark. That is when the second stage will cut off. And soon after that, the HTV-3 cargo carrier itself will separate from that second stage at 15 minutes, 11 seconds. And then it will be in its preliminary orbit, which again is 200 by 300 kilometers. That is 124 miles by 186 miles. Official launch time tonight was, as planned, 9:06 and 18 seconds. The International Space Station was 255 statute miles over the South Pacific Ocean, just off the coast of Chile. It's a live look inside the Tsukuba Space Center. They're just outside of Tokyo. That is the home of the Japan Aerospace Exploration Agency. They're taking a look at their cargo vehicle as it continues to head into space 13 minutes and 22 seconds into the flight.
第2段エンジン燃焼停止。
Second stage engine cut off.
Second stage cutoff confirmed.
ロケットは現在完成飛行を続けています。
The launch vehicle is in coast flight.
Now 14 minutes and 32 seconds into the flight. We're standing by. The vehicle is currently coasting. We'll get confirmation here shortly that the HTV-3 has separated from the second stage itself.
HTV-3 分離。
HTV-3 separation.
HTV-3 has separated 15 minutes and 5 seconds into the flight. The team there in Japan celebrating the HTV-3 in its preliminary orbit, once again 200 by 300 kilometers.
国際宇宙ステーションへ向け、今希望の船で。
Here's a live look at it as it separates and continues on its orbit.
It was full of hope to the JAXA is waiting for its arrival.
これをもちまして、
The team is confirming that HTV-3 did separate cleanly. So the whole liftoff and flight into space for this third cargo carrier is part of the HTV series. Went as expected, right down the line, everything green.
今後のコウノトリ3号機の状況につきましては、記者会見並びにプレスリリースにて発表いたします。
The flight status of the Konotori 3 will be announced at the press conference as well as through press releases.
種子島宇宙センター竹崎総合司令塔よりお伝えしました。ありがとうございました。
This report was from the Takesaki Center at the Tanegashima Space Center. Thank you very much for listening.
This is Mission Control Houston. Again, to summarize, liftoff of the HTV-3 occurred at 9:06 and 18 seconds this evening. The weather was really the only iffy thing there about tonight's launch. The cloud deck was pretty low. There was some rain in the area. It's very humid there. The temperature was about 82 degrees. We lost our visual of the rocket just a few seconds after liftoff, but that has happened before with these launches, including several different shuttle missions, if you remember back in history. But the flight of the HTV-3 went true and as expected. The teams there in Japan, as well as at the other control centers, including here in Houston, monitored everything. Everything went right down the timeline as expected. Everything now set up for the arrival of the HTV-3 coming up next week, just 1 week from today. This cargo vehicle will arrive in the vicinity of the station and will perform a series of rendezvous maneuvers and other fine-tuning of its orbit between now and then. The capture of the HTV currently scheduled for Friday morning at 7:04 a.m. Central Time, 8:04 a.m. Eastern Time. There will be two different Expedition 32 crew members involved in this. Joe Akaba will be the lead robotics person for the actual capture of HTV-3. After that takes place, he will hand over to Aki Hoshide. He will be responsible for actually bringing it in and installing it on the Harmony node itself. We will have two different broadcasts that day, the first one beginning at 6 a.m. Central Time. That will lead us to our capture, again at 7:04. And then our live berthing coverage will begin at 9:30 a.m. Central Time. Of course, berthing will take place is a variable time depending on how fast the crew moves, but we'll have live coverage of it here on NASA television. So again, at 6 a.m. Central Time, live capture coverage, with capture taking place at 7:04, and then live berthing coverage at 9:30 a.m. Central Time here on NASA television. A couple of programming notes before we get ready to wrap up here on NASA television. We want to remind you that coming up on Sunday, that is when the Progress 47 will be undocking from the International Space Station, specifically the Pirs docking compartment. It's going to be undocking and redocking just a day later. It's going to back out to 100 miles back behind and away from the station. We'll have live coverage of that beginning at 3 p.m. Central Time, with the undocking at 3:27. Then on Monday, it's going to redock, reapproach the station. We'll have live coverage beginning at 8:15 p.m. Central Time, with the actual redocking at 8:57. This is being done to test out brand new Coors equipment, both on board the Progress and inside the station. This will help simplify the automated rendezvous and docking process that these Progress and Soyuz go through. So they'll be testing that out, and then the final undocking will occur on Monday, July 30th. At 1:11 p.m. Central Time. And then on Wednesday, August 1st, we'll have launch coverage at 2:15 of the very next Progress, the Progress 48. It'll take up about 2.5 tons of supplies to the International Space Station. The launch at 2:35 p.m. And then an item of note, that Progress is actually going to be docking with the station that same day, just a few hours later. We'll have live coverage beginning at 7:45 p.m. Central Time. with the actual docking at 8:24 p.m. Central Time. So quite a bit of activity coming up for us here on NASA television and the crew of Expedition 32. But again, we want to invite you to join us not only this weekend, but also 1 week from today on Friday morning as this HTV-3 arrives at the International Space Station and the crew gets ready to capture it and install it on the Harmony node.
Eine unbemannte japanische Rakete ist vom Raumfahrtzentrum Tanegashima zur internationalen Raumstation ISS gestartet. Sie hat 4,5 Tonnen Versorgungsgüter und Forschungsmaterial an Bord. Läuft alles nach Plan, soll die Raumkapsel am Freitag an die ISS andocken.
Ein beneidenswerter Job für den Piloten der Royal Navy. Endlich gutes Wetter beim Begleitflug für den ältesten Fackelläufer. Fauja Singh. Ein Inder, 101 Jahre jung, im Stadtteil Newham. Die olympische Flamme hat London erreicht. Gerüstbauer, 1 Kilometer vom Buckingham Palace entfernt und das Besondere, mitten in der Stadt bauen sie das Beachvolleyballstadion auf. Seit die Flamme in der Stadt ist, steigt das Angebot an Unterhaltung und damit auch die Stimmung. Auch auf der kleinen Showbühne direkt neben dem Olympischen Dorf. Die Zahl der Touristen hat sich deutlich erhöht, aber die wenigsten Athleten haben bisher ihr Quartier in Stratford bezogen. Alles ist gerichtet, morgen und übermorgen wird ein Großteil auch der deutschen Mannschaft erwartet. Die Zimmer sind spartanisch eingerichtet, auffällig nur die olympische Bettdecke, die jetzt schon Kultstatus genießt. Ob die Athleten sie mitnehmen dürfen, ist bisher noch nicht geklärt. 6 Tage noch bis zur Eröffnung der Spiele. Wer die Flamme entzündet, wird für alle eine große Überraschung, so versprechen die Veranstalter.
Spektakulär kommt das olympische Feuer angeflogen. Ein Soldat seilt sich mit der Fackel aus dem Hubschrauber ab, direkt über dem weltberühmten Londoner Tower. Die Magie der 5 Ringe zieht die Briten langsam in ihren Bann. Stündlich treffen Athleten ein und erleben eine Überraschung. Soldaten in Kampfanzügen tasten im Olympiazentrum Zivilisten ab, durchsuchen Gepäck. Gäbe es eine Medaille für Versagen, die Sicherheitsfirma G4S hätte Gold sicher. 10.000 Wachleute sollte sie an den Start bringen, gerade mal 4.000 wurden es, also muss jetzt die Armee ran. Die Sportler im Olympischen Dorf sind darüber nicht unglücklich.
Mir haben einige Athleten hier auf dem Olympiagelände gesagt, dass sie sich sicherer fühlen, wenn nun die Kontrollen von gut ausgebildeten Soldaten gemacht werden, anstatt von privaten Sicherheitsleuten, die teilweise nur oberflächlich in 3-tägigen Crashkursen auf diese wichtige Aufgabe vorbereitet wurden.
Viel besser vorbereitet wird die Eröffnungsfeier. Die Proben sind derzeit so geheim, dass sogar der Geheimagent ihrer Majestät beteiligt sein soll. Man munkelt, dass James Bond alias Daniel Craig die olympische Flamme per Fallschirm ins Stadion bringt. Lizenzen zum Zuschauen gibt's für dieses Hochsicherheitsevent ab 2.000 €. Wesentlich günstiger werden Zimmer angeboten. Viele Hotels haben sich verspekuliert. 550 € pro Nacht haben manche 4-Sterne-Hotels vor einem Jahr in London für Olympia verlangt. Nun sind sie runter auf 180 € und die Preise werden noch weiter fallen. So verzweifelt sind viele, ihre leeren Zimmer loszuwerden. London freut sich auf friedlich-fröhliche Spiele. Die Flamme ist in der Hauptstadt. Nun muss der olympische Funke auf die Bevölkerung überspringen.
London ist mit einer spektakulären Aktion die Ankunft des olympischen Feuers gefeiert worden. Ein Soldat der britischen Armee seilte sich mit der Fackel am Gürtel über dem Tower ab. Dort wurde das Feuer von der Läuferin Kelly Holmes übernommen. Gut behütet, gemeinsam mit den Kronjuwelen, hat es dann am sichersten Platz von London übernachtet, im Kerker des Towers. Von heute an geht der Fackellauf quer durch die britische Hauptstadt, bevor es dann am Freitag im Olympiastadion ankommt.
Die weißen Klippen von Dover. So sieht die britische Südküste heute aus. Bis vor etwa 6.000 Jahren konnte man von hier trockenen Fußes nach Holland gelangen oder von Schottland nach Dänemark. Der Meeresspiegel der Nordsee war vor 20.000 Jahren etwa 120 Meter niedriger als heute. Das war die Zeit von Doggerland, wie es die Forscher nennen. einer riesigen Landmasse zwischen Großbritannien und Kontinentaleuropa. Deutlich größer als bisher vermutet war dieses Land, das britische Wissenschaftler jetzt auferstehen lassen. Doggerland, das waren sanfte Hügel, die in fruchtbare Täler führten und hinunter zu weiten Küstenebenen. Es muss ein wunderbarer Ort gewesen sein mit angenehmem Klima im Herzen Europas. Es war der Ort, an dem man damals leben wollte. Ein paradiesisches Land mit fischreichen Gewässern, in dem nach der letzten Eiszeit tausende Menschen lebten. Eine Art europäische Indianer, die als Jäger und Sammler in kleinen Familienverbänden von Jagdgrund zu Jagdgrund zogen. Im Lauf der Jahrtausende verschlang das Meer immer größere Teile dieser prähistorischen Landschaft. Topografische Messdaten, geliefert von Ölarbeitern, ermöglichen deren Rekonstruktion. Vor den schottischen Orkney-Inseln stießen die Wissenschaftler auch auf steinerne Zeugen dieser Zeit. Und in Wales werden die Reste versunkener Wälder aus dem Schlick gehoben. Mal sehen, was die Wissenschaftler als nächstes ausgraben.
Dunkle Wolken am Himmel, windig ist es. Gut, wenn man da eine Mütze aufhat, die einen wärmt. Sommer soll das sein, eigentlich. Nur dieses warmwohlig sonnige Gefühl, das will sich nicht einstellen.
Das Wetter, das zieht einen runter. Immer dunkel, als wenn es Nacht wäre, das ist nicht schön.
Dass es einfach zu kalt ist. Dass es viel geregnet hat und man nicht viel draußen sitzen kann, immer warm angezogen sein muss. Das gefällt mir nicht so.
Das Ganze nass, die grauen Wolken, jeden Tag nur dunkel, keine Sonne. Widerlich.
Und mal ehrlich, es reicht jetzt wirklich. Wir haben keine Lust mehr auf Frust und genau deshalb fliehen all jene, die ohne Hoffnung sind, die nicht mehr glauben an die sonnige Seite des Sommers, via Flieger in den Süden, weil es da so viel mehr gibt, auf das man sich freuen kann.
Prinzip Sonne, Strand, gutes Essen, Prinzip alles.
Abschalten, nichts tun und natürlich schönes Wetter.
Dabei müssen wir nicht mehr lange ausharren. Dabei haben wir es doch bald geschafft. Er kommt doch der Sommer in ein paar Tagen schon. Und dann können wir wieder all die schönen Dinge mit ihm anstellen, die wir so gern mit ihm tun.
Schwimmen, in der Sonne liegen, einfach das Wetter genießen mit Freunden.
Dass man mal abends auch wieder vor die Tür gehen kann und nicht nass wird dabei, dass es halt trocken bleibt.
Die Sonne und kaltes Bier, auf der Terrasse sitzen, keine Schnecken mehr im Garten.
Ich werde mich auf mein Motorrad setzen und erstmal eine Runde drehen.
Ja. Auch wenn es nach all der Tristesse wirklich schwer zu glauben ist, auf Regen folgt Sonnenschein und Hitze. Ganz ehrlich, echt, versprochen.
Kaum zu glauben, aber wahr. Es ist Badewetter. Und um das Glück ganz perfekt zu machen, fehlte nur noch diese Nachricht.
Aber morgen soll es noch wärmer werden.
Endlich Zeit für all das, was wir seit Wochen schon tun wollten, Grund genug, um wunschlos glücklich zu sein.
Jeden Tag hier, von morgens bis abends. Sonst nichts.
Und den Fliegern gen Süden muss heute niemand sehnsüchtig nachschauen, denn auch die Großstadt hat bei diesem Wetter ihre Reize. Dabei ist es vor dem Museum sicher schöner als drinnen, egal welche Ausstellung gezeigt wird. Und dann sind da noch die Biergärten und natürlich die Spree.
Die Stimmen hier, einfach rumzuliegen, nichts zu tun, perfekt.
Sich sonnen, an See fahren, das Wetter einfach genießen, weil man weiß ja auch nicht, wie lange das ist in Deutschland. Das ist ja immer so ein bisschen gewagt.
Heute aber scheint endlich die Sonne und bis zum Wochenende soll das so bleiben.
Guten Abend. Wir haben ja gerade gesehen, wie Deutschland den Anfang des Sommers genießt. Und jetzt schauen wir mal, ob das auch so bleibt. Das kräftige Hoch liegt jetzt hier genau über uns. Über Italien dagegen, da dreht sich ein Gewittertief, was auch rund um die Adria noch Schauer oder Gewitter bringt. Und auf der Strömungsanimation, da sieht man, das Sommerwetter geht auch in den nächsten Tagen so weiter. Es wird sogar noch etwas heißer. Am Freitag dann der Höhepunkt mit heißer Luft direkt aus Spanien.
Das Flugsboot in der Arktis ist nur knapp an einer Katastrophe vorbeigeschrammt. In unmittelbarer Nähe der Touristen brach ein großes Stück eines Gletschers ab und löste eine meterhohe Flutwelle aus. Ein Amateurvideo zeigt die Wassermassen, die dann auf das Schiff zurasen. Der Kapitän reagierte aber geistesgegenwärtig und manövrierte die Ausflugsgruppe aus der brenzligen Situation sicher wieder hinaus.
A pretty extraordinary view and was surprised that he lived to tell about it, frankly. Jeannie Mose has that story.
He wasn't exactly as cool as ice, but at least there were no expletives to delete when this happened. Oh! Off the coast of Greenland, part of a glacier collapsed, sending a mini tsunami directly at this motorboat. And what did Jens Muller say? Wow! Just about every 5 seconds he said it. Wow! Until the wave hit. The boat was sideways toward the glacier, and when Jens' uncle saw the wave coming, he gunned it out of there. Wow! No one was hurt, not Jens, not the Australian tourists. They were taking sightseeing. Wow! And lest you think the only language Jens speaks is wow.
I've never been this close to dying. I've never been this close to dying before.
The thing that seemed to impress people was the way the shooter held the camera steady and stayed focused instead of ducking and covering. But Jens says that's only because he was looking in his viewfinder.
You know that the screen is pretty small, and on this screen the waves look really small.
Jens, a 23-year-old mechanical engineering student, said the ice was cracking for about 4 minutes before the collapse, and for some reason...
None of us was actually scared.
The boat wasn't damaged until later, when they hit a piece of ice underwater on their way home that damaged the steering. A relative had to come retrieve them. No wonder someone posted, "Is this the prequel to Titanic?"
Iceberg, right ahead! Ice, get ahead!
Iceberg, dead ahead!
Wow! Iceberg, dead ahead, sir!
Tsunami ahead, but thankfully Jens isn't dead, though Wow was a victim of overkill. Wow! Ginny Mo, CNN, New York.
This is Mission Control Houston again. Physical separation has been confirmed on time at 3:26 p.m. Central Time as the two vehicles flew at about 255 statute miles just over the eastern Mongolia. We're getting a look from the external camera from the Progress that has physically separated from the International Space Station. It's just about a minute. The Progress thrusters will fire in a separation burn for about 15 seconds to create a change on the Progress velocity by 0.66 meters per second. The separation burn began. It will last about 15 seconds to create that change on the Progress velocity. Again, that's by 0.66 meters per second. It'll begin an opening rate that will allow the Progress to back away slowly and safely away from the space station. Again, this first undocking and moving away from the space station is an effort to test the new automated rendezvous curves in a docking system. The Progress 47 cargo craft arrived at the space station back on April 22nd, delivering 2.8 tons of food, fuel, and supplies for the station residents. It is now loaded with trash and is equipped with the new Russian Kurs NA docking system. The vehicle will now phase out to a distance of about 100 miles away from the space station. A final retrograde burn for station keeping is scheduled to occur just after midnight at 12:01 a.m. Monday, Houston time. It then will park on orbit in station keeping to perform a series of tests. This new automated rendezvous system known as KURS-NA. If the tests are successful, it will eliminate the need for 4 other antennas of the docking system.
Good morning to you from Mission Control Houston. It is Monday, July 23rd, 2012. This is a live look inside the International Space Station Flight Control Room here at the Johnson Space Center. We want to welcome you to today's ISS update. It is a busy day for the crew of Expedition 32 on board the International Space Station. This team here in Houston today is being led by Flight Director Tony Sikachi. He is there on the right-hand side. Sitting beside him is Tomas Gonzalez-Torres. He is the on-console flight director that is training. He, of course, is a former spacewalk officer. Namely, he did STS-125, which was the final mission to the Hubble Space Telescope. But he's been learning how to be a flight director over the last several months, and he is training there with Tony Sikachi. The crew on board currently consists of Gennady Padalka, Sergei Revin, and Joe Acaba, which you see there on the far right-hand side. There's Revin, and then Padalka second from the right. Joe Acaba there in the middle. The newest half of Expedition 32 is there on the left-hand side. That is Aki Hoshide on the far left side of the screen. Yuri Malenchenko there second from the left. And Sonny Williams there in the middle, right beside Acaba. The big news of today is that the crew is in the middle of operations getting ready for the redocking of the Progress 47 cargo vehicle. That cargo craft undocked from the station, the Piers docking compartment, last night at 3:25 p.m. Central Time. It backed away from that docking compartment, performed a 16-second automated separation burn as it backed away from the Russian segment of the International Space Station. And it moved out to a distance of about 100 miles away from the orbiting complex. It is going to be redocking later on tonight at 8:58 p.m. Central Time. We'll have live coverage here on NASA TV at 8:15 p.m. The reason it is doing this is to test out some brand new KURS equipment that is on that Progress spacecraft. KURS is the device and the technology that allows these Progress and the Soyuz to automatically rendezvous and dock with the Russian segment of the International Space Station. They have upgraded some of these systems that will allow it to perform an easier docking and also use fewer antennas on board. So this Progress 47 backed away yesterday afternoon and will redock tonight to the very same docking compartment. Again, we'll have live coverage tonight beginning at 8:15 p.m. Central Time, with the actual redocking taking place at 8:58 p.m. Central Time. In order to support this, the crew has a split shift of a sleep period today. The Russian crew will go to sleep at 10 a.m. Central Time, about 1 hour from now. They'll sleep for about 5.5 hours. They're going to wake up at 3:30 p.m. Central Time. They will support the Progress redocking that we just talked about, and then they'll go back to sleep at about 10:30 p.m. Central Time, and we'll sleep for 9.5 hours, waking up tomorrow morning at 8 a.m. Central Time. The U.S. side of the crew will go to sleep at their normal time of 4:30 p.m. Central Time later on today. They'll sleep for about 3 hours and 15 minutes. They will wake up at 7:45 p.m. Central to support the Progress, and then they will go back to sleep at 9:15, sleep for about 5 hours, 15 minutes, and then we'll wake up about an hour and a half later than they normally would at 2:30 a.m. Central Time. So a split schedule for the crew today. All of this in order to support this Progress redocking, which will take place later on tonight. However, there is some experiment work taking place today while the crew is up getting ready for tonight's activities. Sonny Williams has been working on an experiment that we've talked about before called BASS. This is the Burning and Suppression of Solids experiment. This is one in which they take a look at how flames behave in space. There's different types of materials that they burn up there. There's different types of fuel samples. This experiment is very interesting because it takes a look at how you extinguish a fire, which fire obviously behaves quite a bit differently up in space. Here on Earth, if there's a flame, you typically would aim your extinguisher or whatever you're using to put it out down at the base of the flame. That's because that's where the air enters the flame. It's where the flame is most stable. But of course, up in space, you don't have that kind of effect. So how you would put out a fire up there in zero gravity is quite a bit different. This is a look inside that glove box where the BASS experiment resides. You see one of these small spheres, these fuel spheres burning as Sonny Williams performed this experiment up there in the weightless environment of space, taking a look at these flames. Williams is also busy taking some sound measurements today using what's called an acoustic dosimeter. She's also reviewing procedures for medical ultrasound operations, and she also has a ham pass later on today where she will use the ham radio on board to talk with some students and some people at the Rochester Institute of Technology there in New York. And she's also working on an experiment called VIABLE. That stands for the Evaluation and Monitoring of Microbial Biofilms inside the ISS. And she also has some crew orientation time, which, you know, having just been there for a few days, she and the rest of that Expedition 32 crew is still getting used to their environment up there. Of course, most of them have been up there before, but they still take some time to learn the new surroundings and the emergency procedures and all of that. Aki Hoshide is working on the functional checkout of the diagnostic kit and medical laptop on board. He is reviewing reference material for the integrated cardiovascular experiment, which is one of the experiments on board that takes a look at how the human body, and namely the heart and the muscles and the veins, react to being up in space. And he is also doing some onboard training, getting ready for the arrival of the Japanese HTV cargo ship, which you see there, broken out the different sections. That pressurized logistics carrier, which you see on the far left-hand side, that is the portion that will be mounted to the space station. There's also an exposed pallet down there in the unpressurized logistics carrier. This HTV can carry up items both pressurized and unpressurized, and the crew will take care of unloading all of that cargo over the next several weeks. But HTV launched last Friday night, which you're seeing playback of here. It was quite a rainy and cloudy day there at the Tanegashima Space Center. But the Japanese HTV-3 cargo craft on board its H-2B rocket, which is just a gigantic rocket, did lift off on time at a little after 9 p.m. Central Time. That was 11 a.m. there locally. Quite a cloudy day. There was some rain in the area, and the rocket disappeared into the clouds just a few seconds after liftoff. But it did have an uneventful and successful 15-minute ride into orbit. It is currently on its way toward the International Space Station, and then it will rendezvous and berth Friday evening. We'll have live coverage of that, of course. The grapple scheduled for 7:05 a.m. Central Time, 8:05 a.m. Eastern Time there Friday morning. Joe Akaba will be in charge of actually performing the robotics operations, grappling that cargo craft, and then Aki Hoshide will take over after that, and he will be the one actually installing it on the Harmony node of the International Space Station.